Hello, Mr. Rubo here. Today we're going to look at page 4-14, number 3, and then 4-12, numbers 1 and 2. So I do want you guys to try them on your own, and then I'll watch the videos to just kind of double check. And I give you the little explanation along the way, or you can obviously just look at the key to see that. All right, so we're given circle O and angle B is congruent to angle C. So we want to say that AO is perpendicular and bisects BC. So let's get going. So the first thing is we're given a circle. And then you can kind of see I had already drawn it. But the first thing I do is draw BO and CO. And the reason I can do that is 2 points determine a line. So I don't need to really state too much more there. And then I also know they are congruent because if 2 segment radii of circle, then they are congruent. And then angle B is congruent to angle C. So right there, we have that. So we have that these are congruent. Just kind of marking up my diagram. We have the angle and angle are congruent. So then we can then state, oh, well, if I have my base angles congruent, then their sides are congruent, their opposite sides. So that's why I have AB is congruent to AC. And then last, or not last, but I know that AO bisects BC because if 2 points are equidistant from endpoints of segments, then they determine perpendicular bisectors of segments. Technically, you could go the longer route, and you could, if you really wanted to, you could say, AO is congruent to AO by the reflexive property. And then you have side, side, side for the 2 triangles, and you can do all of that and get your triangles congruent, and then you can prove that these 2 triangles are congruent and these 2 triangles are congruent. And then you can say, oh, there's a longer proof to it, but if you use this reason, this will save you quite a few steps. Okay. So it's a pretty nice reason if you remember it. Okay. And then we're going to go ahead back to page 4-12. Going to go a little bit back, and we're just going to do numbers 1 and 2. So again, try these out real quick. Pause the video if you need to, and then come back and see if you got them right. All right. So an altitude of an equilateral triangle is also an angle bisector. True or false? The fact that there are 2 right angles is given information. So, one second. Sorry about that. All right, so here we have the statement, and we really just need to kind of determine what's actually given, what's not, because this is, a little warm up for the quiz. So as far as what's given here, the first part, the fact that there are 2 right angles is given information, is not given, right? We can easily deduct that we have some right angles, right? Based on the fact we have an altitude, but we can't just say we have right angles. We have to give a reason. So because of that, it is not given. All right, and then for part B, true or false, the fact that the altitude is the angle bisector is given information. Well, that is also false. So hopefully you got those 2 right. It is not given information. That's what we're trying to prove based off that sentence. Okay. And then the last one, sometimes, never, always. The median of a right triangle is also an altitude. So that is sometimes. If you think about, here right now, if I draw an median from this segment, let's do it in a different color. Do a median from here, from this vertex to this segment. Well, the altitude would be actually this side as well. So those are definitely not the same. But if I have a specific triangle, a specific right triangle, specifically a 45, ooh, that didn't keep it small, a 45, 45, 90, and I go from the vertex that is the right angle, because it's isosceles, this altitude is actually also the median. So there's really the only time that's going to happen, for right triangles at least. So that is why it is sometimes. All right. Thanks for watching and good luck on your quiz.